मैं थोड़ा सा ना just a little bit about ions, ठीक है? Actually, I'll share the board link as well. Just a little bit about ions. Okay, we did. Okay, that's your pure table, ठीक है? That's in front of you. So we figured out how to figure out protons, neutrons, and electrons, ठीक है? So just 1 second, let me open the board. So we figured out proton, neutrons, and electrons. But if you look at the pure table, ठीक है? You've got groups and you've got एक सेकंड अच्छा you've got groups and you've got periods, ठीक है? इसको एक सेकंड में कॉपी कर लूं. ठीक है नीचे. अच्छा, I wanted to discuss a bit more about ions. So let's keep this pure table in front of us, ठीक है? That's a pure table. अच्छा, which side, ये थोड़ा सा discussion हुई थी, but I think before doing the past paper questions, this is important to complete this discussion. Which side, does anyone know which side is metals and which side is non-metals?
So the left side is metals and the right side is non-metals.
Okay, so the left side is your metals and this right side, that's your. So that's your non-metals, okay? That's the first thing. Or specifically there's a staircase which starts below boron. Okay, so elements that are around the staircase, they're called metalloids, which basically means that they have properties of both metals, metallic and non-metallic properties. Okay? That's how the staircase goes. I remember this line is not it's not a rigid fixed line. Okay? Over here, if you're on the extreme left, that's metallic. If you're on the extreme right, that's non-metallic. Okay? Things that are in the middle are kind of something, they're kind of mixed. Okay? So there's this gradual change that happens when you move from left to right. When you move from metals all the way to non-metals. And the property of the substance changes a lot. Okay? There's a lot of change in the properties of substances when you move from metals to non-metals. Can anyone tell me one major difference between a metal and a non-metal? What's the one major? How do you differentiate between a metal and a non-metal?
Metal conducts electricity. Metal is hardened.
So metals, they conduct electricity, that's fine, right? Non-metals, I mean, these are properties, right? What I'm saying is, what's the one major difference in definition? How do you differentiate between a metal? I'm not talking about properties. The properties are obviously different. Metals are shiny, they're lustrous, they're sonorous, they conduct electricity. I mean, you know what a metal looks like, right? Non-metals, like the wood in front of you, it's non-metallic. It's non-metallic substances. They don't do all of that. So one major difference, Amna, do you know what's the major difference between a metal and a non-metal? Yeah, कोई भी, anyone. I remember this.
The electrical conduction.
What's the?
There's the electrical conduction.
So I'll tell you. I mean, one basic major difference, right? Metals, they like to lose electrons. That's the one. I mean, the way you know something is a metal is that they like to lose electrons. I mean, the properties are different. Properties are separate. We're going to study the properties later on. But according at the atomic level, when you have an atom, if it's a metal atom, it likes to lose electrons, and it likes to forms positive ions, which are cations. And your non-metals on the other side, the one basic difference is that non-metals, they like to gain electrons. Okay, that's one basic difference. And when they gain electrons, they form negative ions, which are known as anions. So those are your anions. Anyway, so that's the major difference. Now the question then is, why does this happen? When you move from left to right, the atoms over here, they like to lose electrons. The atoms on the other side, they like to gain electrons. So what's the reason? What's happening when you move from left to right, right? So let's say I've got lithium over here and I've got fluorine on the other end. One of them likes to lose electrons. The other one likes to gain electrons. Let's look at lithium. Okay? I'm going to draw lithium first. So lithium ka likha hua hai, it's 3 and 7, right? So it's 3 and 7. So how many protons? One second. How many protons does it have?
3.
Yeah. Yes, you got 3 protons. You got 3 electrons, and you got 7 minus 3 difference. That's the number of neutrons, right?
4.
So 4. Okay. So if I draw the lithium atom, it's 3 protons, 4 neutrons are in the nucleus, and so there are going to be 2 shells. The electronic configuration is going to be, what's the electronic configuration? That's 2 and 1, right?
2, yes.
Well, that's 2 and 1. So I've got 2 electrons and I've got 1 electron in the outermost shell. And then I have fluorine. Okay, that's the other corner. Okay, that's
9 and 14.
okay, that's 9 and 19. Okay, that's fluorine. So that's the other corner. So fluorine would be 9 and 19. So that means the smaller number, that's the number of protons, that's the number of electrons, and that's the difference is 10 neutrons, right? So I've got this, and the electronic configuration 9 electrons. That's going to be 2 and 7, right? So the nucleus will have 9 protons, and it's going to have 10 neutrons, and it's going to have. So this one is going to have a total of 7 electrons. 2 in the first, and 9 electrons total, 2 in the first, 7 in the second one. Because that's what an atom of fluorine looks like. Here, that's your atom of fluorine, and that's your atom of lithium over here. By looking at the atoms, why do you think this one over here likes to lose electrons, and why does this one like to gain electrons? What could be the reason?
To the fact that it only has 1 electron in its most outer shell, the lithium one, and when it will lose an atom, the fluorine one will gain an atom, so it will be complete. Both the atoms will be complete.
Okay, I think that is exactly true, but again, that is, but the reason is not there. I mean, this is exactly what's going to happen, but you didn't tell me the reason. Okay, why does this like to? Why does it not? I mean, this electron, it's going to lose that electron, right? You're right about that. And so the problem is, why is it not attracting that electron? So the question is, who attracts the electron in the first place? It's the nucleus, right? The nucleus has the positive charge. The nucleus is the thing that keeps the electron attracted to it. I mean, that's why all the electrons, the protons are positively charged, right? So it's the nucleus that is the one that's attracting this electron. So what is the difference between the nucleus of lithium?
It has a stronger attraction.
Yeah, exactly. So what's happening is, yahan pe na, there are 9 protons, right? Over here, there are 3 protons. So this is plus 9. The nucleus is plus 9. It's a lot stronger positive charge. this nucleus over here. So you've got two positive charges, nucleuses, right? One of them is, I mean, this one over here, the fluorine one, that's very strong. Okay, that's got a very strong. This one over here, it's got a very strong positive charge. So what it's going to do is, it's going to pull that electron and keep it with itself. So reason समझ आई? Reason, ठीक है? Why is this losing electrons? Because its nucleus doesn't have a very strong positive charge. Is that clear?
Yes.
So the electron is going to fly off. It's going to get attracted to the nucleus, the more stronger positive nucleus over here. Is sound clear? Is this clear to everyone?
Yes.
Right. Abu Bakr? No, Shema, Urwa, is this clear?
Yes.
It is clear.
Okay. And so the reason is, coming back to this, I just wanted to explain to you, because remember, it's all of chemistry. When we study chemistry, it's all about losing and gaining electrons, right? That's what's happening. So why do metals always tend to lose electrons? Because they have very few protons in the nucleus. The nucleus does not have a very strong positive charge, which is why they always are losing electrons. किसी भी row में देख लो, you look at potassium, 19 protons, right? If you go all the way to the other side, bromine over here has 35 protons. So bromine, if you put potassium next to bromine, bromine's nucleus is it's got a very strong positive charge, and it will gain electrons, and it will steal those electrons from potassium, right? So the point is, why are metals always losing electrons? Because they're always having very few protons in the nucleus. And so they always lose electrons. That's why they're metals, right? And this tendency decreases. When you move to the right, the number of protons, they continue to increase. This one has 20 protons, 23, 24, 25. Zinc has 30, right? So now it's becoming harder to lose electrons because the nucleus over here has more protons, right? So it becomes harder to. And then when you move towards non-metals, they've got too many protons in the nucleus that they start to gain electrons, right? So remember this point. Okay, the periodic table is divided into two parts. One part is metals and the other part is non-metals. And something happens when you put a metal next to a non-metal that. So the question is, how many electrons will it lose? The metal. Remember, it will only lose this outer electron. It will not lose these two electrons. What's the reason? Why doesn't it lose all three electrons? Why just the outermost? What's the reason? Like it loses.
Because it's the closest.
Because they're closer. When you're closer, there's more attraction, right? So it's a lot harder to lose this electron, right? This outer one is like really far away, so it's easier to lose that electron. So remember this: when metals lose electrons, they only lose outer shell electrons or valence electrons. But it's going to be extremely hard to lose these electrons because they're very close to the nucleus. So they're very strongly or tightly attracted to the nucleus over here. So then this one, if fluorine is to gain an electron, how many electrons can it possibly gain? Can it gain more than one electron? Like if it gains that one electron, can it gain more? And what's the reason for that?
Because there's no more space.
There's no more space, right? So the non-metal will continue to gain electrons until there's no space left, right? So only valence electrons are lost over here. Wait a second, valence electrons lost only. And this one gains electrons until its valence shell is complete. So until the valence shell is complete. So what you state is that atoms, they like to form ions, right? Whenever you have a metal, the metal would always lose its outer shell electrons to someone. someone is going to come and steal those electrons away from it because it's not attracting those electrons very strongly in the first place. Okay, so the electrons that are in the outermost shell, the metal atom would always tend to lose those electrons, right? But it's only going to lose the outer shell electrons, not the inner shell electrons, right? And the non-metal will continue to gain electrons. It's going to, it's going to see atoms, it's going to steal those electrons from those atoms, right? It's going to continue to fill its electrons, but it can only, there's going to be an upper limit. It can only do that until the valence shell is complete. So you make a statement which is that both metal atoms and non-metal atoms, the stable electronic configuration is a noble gas electronic configuration, or you can say a complete octet. Okay, all atoms, this applies to all atoms, whether it's metals or non-metals. They like to have a stable electronic configuration. And you already know that. I just told you the reason why they want to have a stable electronic configuration. Actually, they don't even know whether they want to have a stable electronic configuration. It's just that naturally its outer shell will be complete and naturally its outer shell would be lost eventually. Because it's a nucleus that's not attracting electrons that strongly, so it's going to lose the outer shell electrons eventually. And its nucleus is attracting electrons too strongly, so it will continue to attract electrons until it's complete. So all atoms like to have a stable electronic configuration, which is, what is a stable electronic configuration? A complete octet, or also referred to as a noble gas electronic configuration. Because noble gases, their outer shells are always complete. So electronic So noble gas electronic configuration. And then you have another thing, which is that metals do this by losing electrons. So they lose outer shell electrons. And vice versa, non-metals, they do the exact opposite. Until valence shell gets completed. And both of them, they turn into ions. Okay, so they like to form ions, right? And we can highlight this. So ये तो सारों को पता है ना, noble gas configuration, right? I mean, the atoms like to form noble gas configuration. Is that clear?
Yes, sir.
Yes, sir.
So the next thing is, I'm just going to talk about ions, right? So what did we talk about group 1, right? Remember group 1, 2, 3? These are metals. I mean, there's at 3 things get divided, right? There's confusion over here, but what we're going to state is that up till 3, most of them are metals. After that, the right side, they're non-metals, right? So just tell me the charges. What will be the charge on the atom based on the group number? Like if I talk about this one. So if I talk about group 1, metal or non-metal?
Metal, sir.
So that's metal. So how many electrons will it lose? How many valence electrons will it have? Group 1.
Sir, 1.
You can remember group number is the number of outer shell electrons. So it's going to lose. It's going to lose.
It's 3, I think.
3 kya? 3 kya? Group 1 means any element that's in group 1, right? Okay, where's the periodic table? Group 1 will always have one electron in its outer shell. 3 ka matlab kya? That's 2 and 1, right? 11, that's 2, 8 and 1. You've got potassium, that's 2, 8 and 1. So every group 1 element will have one electron in its outer shell. Is that clear?
Yes, sir.
So it's a metal, it's going to lose electrons, right? So it's going to lose one valence electron. So it loses one valence outer shell electron. So one valence electron lost. So vice versa, if I have group 2, right? So that's also a metal, right? And it's going to form an ion as well. And it will form an ion with the charge of +2. Why? Because group 2 ka matlab hai it's got 2 valence electrons. So it loses
Valence electron.
2 valence electrons. And then similarly, you have group 3. Group 3 ka issue hai it's mostly metals, right?
Yes, sir.
I just showed you that when you reach group 3, then there's a confusion, right? It's top pe there are non-metals staircase. On the left side of staircase, these are all metals. Right side, so group 3, most of them are metals, right? The top one, boron, is kind of an in-between. Usko nahi pata if it wants to lose electrons or gain electrons. So group 3 is mostly metals, and it will have a charge of +3 because it's got 3 valence electrons. It's going to lose. So it loses 3 valence electrons. इसको भी हटा ही देते हैं. अच्छा, then so on. You've got group 4. They don't usually form ions, and group 4 is mostly metalloids. They're kind of in between. They're neither metals nor non-metals. They sometimes lose electrons, sometimes gain electrons. I said, remember, in O-levels, you don't have to go into that much detail. You don't have to be very specific. So we'll just stick to what I'm writing over here. Group 6, group 7, okay. I said, what happens to non-metals? When you move past group 4, okay, group 4 ke upar, it's kind of a mix. It's metals and non-metals. But when you move past group 4, 5, 6, 7, they're mostly non-metals, right? So what happens over here? Group 5 ki baat kar lein. You've got how many valence electrons in group 5? That's 5. So how many would it gain to get a noble gas configuration?
3, sir.
3. So it's going to be -3. Okay? So group 5 are going to be non-metals mostly. And it's going to have a charge of -3. Why? Because it's going to gain 3 electrons. Then group 6 would be, as a group 6 is going to be, kya charge hoga?
Sir, -2, sorry.
-2. It already has 6 electrons, it's going to gain 2 electrons. And this one, group 7, is going to have, it's a non-metal as well. It's going to have a charge of -1 and it gains 1 electron. Okay, so, but remember the basic idea that metals and non-metals, the main difference is that they like to lose electrons, and they would only lose the outer shell electrons. Andar wale electrons usne pakde rakhe hain, theek hai? It's not going to lose the inner electrons. जो बाहर घूम रहा है ना, that's the one that is going to lose. Non-metals, they would gain electrons, but they would only gain electrons up till the point where the shell is complete. But the end goal is both of them would, at the end of the day, will have complete shells. One of them by losing electrons, the other one by gaining electrons. Okay? So remember this by heart. Okay, what charges do they have when they become ions? So moving back to the question now, we're trying to do the question now. So he's saying an element X forms a positive ion. So is it a metal or a non-metal? Concept groups
Metal,
go.
sir.
And it's going to be in either group 1, 2, or
Three.
3, right? It's going to be some.
Sorry, group 1.
Achha, so he's saying what is the proton number of, so it's going to be a metal, right? So he's saying that it forms a positive ion with the electronic structure 288. So the ion has this structure. So which one could it be?
C, sir.
Yes,
Remember, this is the ion. This is the electronic configuration of the ion. It has already lost electrons. I mean, for example, let's look at 16, right? If the atom had a proton number of 16, and how many electrons is this? This is 18 electrons, right?
Yes, sir.
So how many electrons got added over here? 2 got added.
Yep.
So will this atom over here become a negative ion or a positive ion?
Negative.
It's going to be a negative ion, right? It's going to have a charge of -2. So remember, the question is that this is the atom, and this atom is forming an ion which has this electronic configuration. So if the atom had 16 electrons and the ion had 18 electrons, so that means it gained 2 electrons, but it would become a negative ion, right? What about this one? So this one has 17 electrons, this other atom, right? If it were to become this ion, it will need to gain how many electrons? It's going to gain 1 electron, right? So again, what would be the ion? A -1 ion, right? Similarly, if the atom had 18 electrons, the ion also has 18 electrons, then it will never become an ion because it never needs to gain or lose electrons, because you can only form an ion if electrons are lost and gained, right? So it can't be 18. Okay, if the atom had 18, then that means no electron lost or gained, right?
Yes, sir.
So the atom cannot have 18. To become an ion, it has to lose or gain electrons. What about 19? If it had 19 electrons, so that means what?
One.
It will gain 1.
19 say if it becomes an ion,
It will lose.
it's going to lose electrons, right? So and it's going to exactly lose 1 electron. If it loses 1 electron, it's going to form a positive ion, so that a +1 charge will appear on it. So it's going to be D. The answer to this one is, so the answer to this one is D. Do you get the point that the electronic configuration is for the ion? And they're
Yes.
saying that this is a positive ion. So if this atom were to form an ion, okay, 19 से वो 18 पे चला जाए, so if it wants to form an ion, it's going to lose 1 electron, right? So when an atom loses 1 electron, it's going to form a positive ion. And that's what they're saying, that so this is the only one that's capable of forming a positive ion. Or you could have answered this the other way around as well. You could have opened the periodic table. उससे positive ion कहा हुआ था ना? So who forms a positive ion? You had 16, 17, 18, and 19, right? So you could have just opened the periodic table. 16 is sulfur, so it's going to form a negative ion. 17 is chlorine, it's going to form a negative ion. 18 is argon, it's never going to form an ion. Or 19 is potassium, that's the one that's going to form a positive ion. Is that clear?
Yes.
Yes, sir.
So which statement about the number of particles in atoms is correct? Apart from hydrogen, most atoms contain more neutrons than protons. So is that statement correct or not? So apart from hydrogen, right? And it's a general statement, most atoms. So we're going to pick some atoms and we're going to try and figure this out. More neutrons than protons, right? So open this up, more neutrons. Dilip, okay, this one, let's pick lithium. How many neutrons? That's 4. How many protons? That's 3, right?
More.
So you got more neutrons than protons.
Yes.
I said then this one, you've got how many neutrons? That's 5. And how many protons? That's 4, right? So again, more neutrons than protons. So is it a general statement? Let's look at titanium over here. 22 protons and what's 48 minus 22? That's 26.
48 minus 22 is 26.
So again, it's more neutrons than protons. So I guess
Correct.
So I guess that's correct. It appears to be correct, right? This one is obviously the other statement is wrong. C and D are obviously wrong because atoms, he's talking about atoms, right? So whenever you're talking about atoms, they have equal number of electrons and protons, right? So ये दोनों तो वैसे ही गलत है. अच्छा, this one. What is same in between these two? What's same?
The number of neutrons.
You get the number of neutrons. 65 minus 30, that's 35 neutrons. And 64 minus 29, that's also 35 neutrons. So number of neutrons, that's same. What is the nuclear number, Vese, by the way?
The proton and the neutron.
Proton plus neutron, that's 64 and 65. That's the nuclear number. Protons are obviously different, 29 and 30, right? I said this one, strontium. How many protons and electrons?
Protons 38, both 38.
Yes, and neutrons, they are 52, and the electrons, it's saying that it's lost 2 electrons. So 2 minus 38 minus 2, that's 36. So the answer is A.
Okay, so it's going to be 36, right? So answer is E. Okay. Remember, plus 2 means it lost 2 electrons, right? It would have the atom would have 38 electrons, but it lost 2 electrons, which is why it has a plus 2 charge. Achha, which of these diagrams is correct? There's a beam of proton, neutrons, and electrons.
D.
Okay, so the electron is going to go towards the negative side. The proton, D is not right.
Oh no, sorry. C.
A.
Oh.
A is correct. A is correct.
A, sir. A.
Okay, the electron is negatively charged. Opposite charges attract. The positive is going to attract the electron. The negative is going to attract the proton. Or neutron सीधा जाएगा, ठीक है? No one is going to attract it. It doesn't have a charge. Why is the electron? Achha, there's another question. Why is the electron deflected more?
So because it has a negative value, so
नहीं, वो तो ठीक है. It's got a negative value. So the proton has a positive value.
it's attracted to the positive value.
नहीं, वो तो ठीक है. But why is?
For attractive force.
Yes, there is more attractive force. But why is there more deflection? Like proton is less deflected towards the negative. Electron is more deflected towards the positive. Why is that? Anyone?
It reacts more.
There is no reaction going on. It's just a deflection. The positive is attracting the electron. I'll cut for you. I'll explain. Okay, what happens is that an electron. What is the mass of a proton and a neutron? It's relative mass. It's 1, and this one is 1. What is the mass of an electron? That's 1 over 1836 or 1840, right? What that indicates is relative
mass.
So what that indicates? Question? What did you say?
It has a lighter mass.
It has a lighter mass, exactly. Okay. Relative mass means we don't know what the mass is. It's 1. This one is. I mean, both of them have equal masses. This one is 1836 times lighter than these two. So there's more deflection. because there is lesser mass. Light particles are deflected more. Okay, the force is the same. Like if you apply the same force to a very small thing, it's going to be deflected more. Okay, clear? Is this clear?
Yes, sir.
Yes, sir.
So you can get a question similar to this, where they might give you two options where one of them would be electron and proton equally deflected, and another one where the electron and proton are unequally deflected. Remember, they're always unequally deflected. I said this one is easy, number of neutrons, right? It's similar to the previous one. What are the number of neutrons? I think 31 minus 15, that's 16.
Yes, sir.
And this one is also 16. I said, let's do this one. Two particles X and Y have the composition shown in the table. So I said two particles X and Y. So are they metal atoms? As a first thing, how is an element identified? Elements are identified by electrons, neutrons, or protons. Which number do you use to identify an element? Yamne kya tha? How? Which number for an element is always the same?
Proton number.
Protons.
You can remember protons. Protons are
Proton
used.
and
Remember, electron number can also change. Atoms can lose electrons, they can gain electrons, right? The neutrons can also change because they are isotopes. Some atoms of the same element can have more neutrons, some can have lesser number of neutrons, right? But the number of protons is always fixed. So I'm going to identify the element based on the number of protons. One is 8 and the other one is 17. So which element are we talking about? Periodic table 8 and 17, right? That's one of them is oxygen. The other one is chlorine. So they're both what? They're both non-metals, right?
yes, sir. So
So they're both non-metals.
Yes,
And, so is this statement correct?
yes, sir.
No, it's not correct. What do you think is wrong with this statement? But there's a very slight issue with this statement. But it's clear that this is oxygen, this is Cl, right? And they're
Yes, sir.
non-metals, right? Why is this statement wrong?
Sir, because
The question is, are they atoms or not? Non-metal wali baat theek hai. I mean, they're
Sir,
obvious,
element.
but are they atoms or not? They're not atoms. Why are they not atoms? Because if they were atoms, the electrons should have been how many? 8 electrons, right? But you've got how many electrons? 10 electrons. So what is the charge on this thing? But it should have 8 electrons, right? But it doesn't have 8 electrons. Instead, it has 10 electrons. So, but what is the charge on X?
Sir, -2.
Okay, so it's got a -2 charge. It's got 2 extra electrons, right? And 17 protons. It should have had 17 electrons as well, right? But it doesn't. It has 18 electrons. So what is the charge on Y? There's 1 extra electron, right? So it's got a charge of
Negative ions, sir. So because it has charge of positive, so that means sorry, it has a charge of
negative ions, right?
yes, sir.
So C is the statement that's correct, right? It's so is that clear? They were obviously non-metals, but the problem was that they're not atoms, right?
Yes, sir.
But ions. And they have specifically negative ions, right? Is that clear, everyone?
Yes, sir.
So next one, this one is easy. It's actually now he's asking for the nucleon number. So what's the nucleon number over here?
235, sir.
Okay, that's 235. Remember this big number over here. That's the nucleon number. That's the number of proton plus the number of neutrons. As this one, an atom of X is represented by 3 and 7. As I remember, elements are identified by the proton number. Okay, so it's got a proton number of 3, and this one is basically proton number 3. Which is proton number 3? That's
Lithium, sir.
okay, that's lithium. That's the one that we just did. So we're dealing with lithium over here. So it is in group 3. No, it's not. It's not in group 3. It's neither in group 7, right? It's lithium, right? Lithium is in group 1. It's the first group, right? It's in the first group. Total number of protons and electrons is 6. Is that true?
Yes, sir.
Yeah, that is true because you got 3 protons, and the atom. I said, remember, be very careful whether he's talking about the atom, because remember they're going to. I mean, past paper questions can be tricky. Just very, very slight different usage of word, and you will get the question wrong. Okay. So an atom will have the same number of electrons, which is 3. So total kya hoga? That's 6. So this statement is correct. What's the total number of protons and neutrons in this?
7.
Okay, that's 7 because the number of neutrons is the difference, which is but protons and neutrons is the nucleon number, right? And that's 7 over here. So that's 7. So the answer to this is C. As which property decides the order of the elements in the periodic table? So,
Sir, D.
So Neem, what number is? How are they arranged according to what?
Proton number.
According to the proton number, right? But we should add this to our notes as well. That because remember, proton number is the most important number. The other numbers can change; they can vary. So elements are arranged according to proton number. Okay, there's another question that they usually ask, which is that how do you know that there are no missing elements in the periodic table? Now, how can you be sure that these are the only elements in the universe and there are no missing elements? I mean, because you've found an element for each proton number. You've got a 3 proton number, the electrons can vary, the neutrons can vary, but the protons, you know that there's an element with 3 proton numbers. There's one with 4, there's one with 5, there's no missing gaps. 25 where you found an element, 26 you found another element, 27, 28, 29. So you found elements for each proton number, right? So which is why you're pretty sure that there are no missing elements, like there's no gaps in between. Is that clear?
Yes, sir.
Yes.
At the end, there might be other elements. Maybe there might be some element which has not been discovered with 119 protons. But these elements I told you are useless anyways, because I told you that the universe is made up of small atoms, mostly first 20. 70 to 80% or 90% of the universe is just helium and hydrogen, the first 2. So these elements are very, very rare anyways. So you don't even have to care about them. Okay, let's do a couple of more questions. So which property of the elements? That's D, right? You arrange them according to proton number. Achha, this one. The outer shell, remember outer shell. For the number of outer shell electrons for the first 12 elements in the periodic table is plotted. So which graph is obtained? So First 12. First element has 1 electron. Second element has 2 electrons. Third element has 3 electrons. 4, 5 electrons. 6. I mean, you don't even have to 7, 8, 9, and 10 and so on. So explain to me, how many valence electrons will the first one have? Like the first element.
Sir, can you please show the question?
Okay. Look at the graph. This is the graph he's looking for. Okay, number of outer shell electrons and the proton number of the element. So if the element has 1 proton, so how many outer shell electrons will it have? He will access. Like 1 proton. 1 proton is hydrogen. How many outer shell electrons will it have?
Sir, it will have 1.
1. एक ही है ना? मतलब और तो है नहीं, that's 1. What about number 2? It's got 2 electrons, right? So how many outer shell electrons will it have? 2, right?
Sir,
So then move to lithium. Number 3. How many outer shell electrons will it have?
1, sir.
It will have 1, because now the electronic configuration is 2 and 1, right? Beryllium के पास कितने होंगे? That's outer shell electrons. 2, right? So it's going to go like this. This one will have 1 electron in its outer shell. This one will have 2. This one will have 1 in its outer shell. This one will have 2. This one will have 3. This one will have 4. This one will have 5. 8 pe kya hoga? That's 2 and 6. 6. Then you have 7. At 10 you'll have 8. 11 pe kya hoga? That's going to be 2, 8 and 1, right? So you'll have 1 again. And 12 pe you'll have 2, 8 and 2. So remember, he's only asking for the outer shell electronic configuration. So which graph do you think is the correct one?
B, sir.
B. I think this one is correct. First one has 1. Second one has 2. Number 3 has 1 again. Then it's got 2, then 3, then 4, 5, 6, 7, 8. यहाँ तक 8 outer shell. At 11, you have 1 again. And at 12, you have 2 in the outer shell, right? So the graph, the correct graph is going to be this one. Is this question clear? Clear again?
Yes, sir.
So just remember, read the question carefully. Okay, what is he asking for? And make sure understand okay, number of outer shell electrons and this. So which ion has the most shells that contain electrons? Most number of shells. Aluminium वैसे 13 होता है. So how many? What's the normal electronic configuration of aluminium? That's 2, 8 and
2, 8.
3. But it's got a +3 charge. So that means what? Okay,
It will lose electrons.
3 electrons, right? So it's got how many shells? It's got just 2 shells, 1 and 2, right? So it's got 2 shells that contain electrons. I said beryllium, that's I think according to the periodic table, that's 4 protons. So it's going to be 2 and 2, right? But it's got a +2 charge. So that means the outer 2 electrons are gone. So it's got just 1 shell, right? I say n pe aa jao, that's proton number is 7. So it's going to be 2 and 5, but it's got a -3 charge. So how many electrons would there be? But if it had been an atom, it would be 2 and 5, but it's got a -3 charge. So kya hoga? What will it be?
2, 8.
So it's going to become 2 and 8, right? But it's still going to have 2 shells, right? Now sulfur is the proton number is 16. So that means a sulfur atom has 2, 8 and 6 electronic configuration, but it's got a -2 charge. So ये क्या हो जाएगा? 8 electrons, right?
Yes, sir.
So it's got 3 shells, right? So D is the answer that has the most shells. So it's got the most shells. So we'll try and do more questions tomorrow. Okay. So we'll continue tomorrow then. So yeah.
Okay, sir.
Okay, everyone. Take care.
Love you, sir.